Alright, this is comparing dot plot student handout 5 from statistics. So make sure you're on student handout 5. First, we're going to go ahead and check homework 4. So I guess turn to homework 4 for us to check. That way we know what we're doing with our MAD problems, our mean absolute deviation. See if we check and know how to do that. So zoom in here. Here is your homework 4 solutions. Here's the first part. And then scroll down to number 2 for the second part. You may need to pause this at various spots to check. Alright, so let's take a look at comparing dot plots. Okay, first, dot plots display data graphically using a small dot for each data piece. The data points are ordered from least to greatest. Okay, the shape of the data can be 3 different ways. You can have symmetric, that's where it kind of makes a staircase up and down. It can be skewed to the right, that's where you have kind of more data points to the right of the graph, or skewed to the left where you have more data points to the left of the graph. The spread is the variability or spread in the data points, describes how far apart the data is from one another. So if I was taking a list of everyone's age in here, most students are 11, 12, some of us are 13, but if I had a 5-year-old come in here, that messes up the spread of my data because I was going from 11 to 13 or 14, and then I have a 5-year-old come in here. Well, now my age range is from 5 to 14 when most people aren't even 5 in here. So if I had a 5-year-old come in here, he's known as an outlier because he doesn't belong in this age group. So this can also be represented by the range. Right, the median and mean both represent the center of the data. The median is all your middle number. The mean is the average of all your numbers. So your middle number here and your mean probably could be something different because you have more data points over to the right. Same thing with this one. Symmetric, you're probably going to have the median and the mean the same number. When the data is skewed to the left or right, then the median is the best representation of the data. So the median is going to show you your best average. So if I had a 5-year-old come in here, he's kind of skewing my data. He's making it go off a little bit for my ages. So I would want to put everybody in order from least to greatest and find the middle person in a row, finding the median. That person's age would be my median of age, my middle number. That would give me the best idea of the ages of students in this classroom. Okay, so if I had a 5-year-old, that means my data was skewed, and median would be the best option to find the average number, because in this class, average is not a 5-year-old. Some of you might act like it, but okay. When your data is symmetric, so when I don't really have a 5-year-old in here, I have just 11, 12, 13-year-olds. They're all in order. Then your mean is the best way to get an accurate measurement of your data. So I would want to add up all of your ages without the 5-year-old and divide by the number of students, and my mean is going to give me the best average for your age in this class. Alright, so we're going to take a look more into some dot plots. Here I have two different classes. We're asked how many minutes each student traveled to school in the morning. So this one is this graph is for room 434. So like my classroom, and then maybe room 425 is Mr. White's classroom. And this is how many minutes it took each student in the class to travel to school in the mornings. So I need to make a dot plot. So all I do is I'm going to put a dot for each value. So I see a number 5. I'm going to put a dot on 5. I see a 7, a dot. I see 2 8s. So I do a dot and then another dot. 2 4s, dot, then another dot. A 7, so I need to add to this 7. Another 5, so I'm adding to that. Another 4. And then lastly another 7. Alright, I have 3, 5, I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I plotted all the dot points for room 434. I'm going to do the same for room 425. So I have a 4, a 5, another 5, a 6, a 3, another 6, another 4, a 7, and 2 more 5s. Okay. There is 3, 6, 7, 8, 9, 10, and there's 10 numbers. Alright, so I just created my dot plots, kind of fun. Number 2 says, describe the shape of the two graphs above. So would you consider room 434 to be symmetric, skewed to the right, skewed to the left, or neither? I feel like 434 would be neither. Symmetric has to be staircases up and down, kind of creating a triangle. This is not creating a triangle. It's not continually going down or continually going up, so I would say this is neither. 425, however, does look symmetric. It's continually going up and then continually going down, so I would consider 425 to be symmetric. So this says room 434 doesn't have a pattern, while room 425, the data is symmetric. Number 3 says, determine the median in each data set. Median is your middle number. Alright, I'm going to change my color pen here. Median, middle number. So I could sit here and cross out to find my middle number. So I see my middle number is a 5 and a 7. So I have 2 left in the middle. So I have to take the mean of those. So 5 plus 7 is 12. 12 divided by 2 is 6. So the median of this data is 6. Find the median here. I'm going to cross out till I get to the middle. There, and 2's in the middle here, and they're both 5, so 5 plus 5 is 10, divided by 2 is 5, so obviously my median here would be 5. That's all they wanted me to do, so the median for 434 is 6 minutes, and the median for 425 is 5 minutes. It asks, what is the difference between the center of room 425 and the center of room 434? Well, the center is your median. We just found the medians. So it asks, what's the difference? Difference means subtract. So what is 6 minus 5? 6 minus 5 is 1. So the difference would then be 1 minute between that data set. Alright, let's take a look at the back. Just copied that graph again so we could use it to answer the questions. Number 5, we're marking these as true or false. First one says the distribution for 434 is symmetrical, while the distribution for 425 is skewed to the left. Well, 434 we considered not symmetrical. 425 is not skewed to the left, it's symmetrical, so I would say that this statement would be false. The median number of minutes in room 425 is greater than the median number of minutes in room 434. Well, the median in room 425 was 5. The median in 434 was 6. The median is 425 greater than 434? No, it's less than, so this would have to be false. Room 434 has a smaller range than room 425. Okay, range is your largest number subtracted by your smallest number. So here, my largest number used is an 8. Smallest number is a 4. You subtract them. 8 minus 4. My range is 4 here. Okay, smallest, largest. 7 minus 3, my range again is 4. So it says this room has a smaller range than this room. No, they're equal, so that would have to be false. The next one says the distribution for room 425 is symmetrical. I agree it's symmetrical, while the distribution for 434 is skewed to the right. Well, this is not skewed at all, so I would have to say that this is false. However, they said it's true, but I disagree with that. It would have to be false. Alright, moving on. Okay, we're going to work with our MAD deviations again, our mean absolute deviation. Here I have room 434 and its data again, and room 425 and its data. We're going to look at its mean absolute deviation, like we did Friday. So I'm going to list these numbers in order from least to greatest. So I had 3 4s used, 2 5s, 3 7s, and 2 8s. I must first find the mean of this data, so I'm going to need my calculator. I need to add up all of those. So 4 times 3 is 12. 5 plus 5 is 10, so plus a 10, plus 7 times 3 is 21, plus 2 sets of 8 is 16. So I get the total of all my minutes is 59 minutes. I divide by the total numbers, and there are 10 numbers. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to divide by 10, and I get the average, or mean, is 5.9. That is important because I need to know what my deviation from the mean is. How far away is this number? So you always take this number and subtract it from your average. Well, 4 minus a 5.9 is going to give me a negative number. It is negative 1.9 away. So these 3 sets of numbers is negative 1.9. I can go ahead and take the absolute deviation from the mean. Absolute means the distance away from 0, and it's always positive, so these turn to a positive 1.9. Alright, next up is 5, so I'm going to take 5 minus a 5.9. That again is going to give me a negative number. Negative 0.9 is those two. The absolute value of that is a positive 0.9. Then I have 7. So 7 minus 5.9, that's going to give me a positive number of a positive 1.1 for those 3 numbers. And it's going to stay positive for the absolute value of it. And 8, again, is going to give me a positive. 8 minus 5.9 gives me a 2.1. And it's going to stay a positive 2.1 for the absolute value. Alright, I need to find now my MAD, my mean absolute deviation. To do that, I'm going to add up these numbers and divide by 10. When I add these up, I've already done that. I'm going to tell you it is 15. And I've got to divide 15 by 10. So that's why I have that slash bar. 15 divided by 10. And when you do 15 divided by 10, you get 1.5 is your MAD deviation. Alright, I would like you to pause the video and try this chart, then come back to the video and I'll go over the chart and we'll review these answers. Alright, let's see how you did on room 425. We had to list the data points in order, and we got that. Deviation from the mean. I had to calculate the mean of this data point, When I added all of these up, I got 50. There are 10 data points, so I did 50 divided by 10 and got my average or my mean to be 5. So I then subtracted this number by 5. So 3 minus 5 is going to give me a negative 2, and the absolute value of that would be a positive 2. 4 minus 5 is going to give me a negative 1s. Absolute value of that is 1s. 5 minus 5 is going to give me 0s, and absolute value of 0s is 0s. Alright, for 6, I'm going to do 6 minus 5, and I get a positive 1. Absolute value of positive 1 is positive 1s. And then 7 minus 5 gives me a 2. Absolute value of 2 is 2. So now I needed to add these up and find the average of that. When I add those up, I got 8. And 8 has to be divided by these 10 numbers to get my MAD score, or my mean absolute deviation. So 8 divided by 10 then gives me 0.8 for my MAD score. Alright, now I'm able to answer these two questions. What observations can you make about the mean absolute deviation for each classroom? Alright, so if you were to look back at your notes on student handout 4 for mean absolute deviation, you would see a bullet that says if a MAD score is close to 0, that means the data values are going to be close to the mean, the average. So this is 1.5, this one was 0.8. This one was really close to 0, which means most of these numbers here are going to be close to my average of a 5. And if you look at them, most of them were either 5 or really close to 5. Okay, the MAD score here is 1.5. Well, that's kind of further away from the data, from 0. So that means your data values here are going to be a little more spread out or further from your average of a 5.9. Yeah, most of them are around a 5.9, which is pretty close to 6. But some of them was a little further away, but it's still pretty close to 0. So what observations can you make? Well, I know my MAD score for room 434 is 1.5. The MAD score for room 425 is 0.8. For room 425 has data that is closer to the mean because 0.8 is closer. There is slightly more variability in room 434, meaning the data is a little off a bit more than room 425. Alright, number 8 says, what is the difference in the centers related to the variability of each classroom? Alright, so we know difference in math means to subtract. So I want to subtract my two MAD scores here. So 1.5 minus a 0.8, and I get 0.7. That's the differences in the center. I did not mean to hit clear there. Alright, I'm sorry, I subtracted the wrong values. The differences in the centers is your averages. And I have an average here of 5 and an average here of 5.9. So if I was to subtract those, 5.9 minus 5, I get 0.9. So the differences in the centers is 0.9. And 0.9, I notice, is closely related to room 425 because 0.9 is awfully close to the MAD score of 0.8 from room 425. So that's basically all that I really noticed. So it's almost, this room here's MAD score is almost double. So that's why the data is a little more spread out. Alright, you're going to work on homework 5. I'm going to be checking that tomorrow. And don't forget that your GeoPacket 2 is going to be due Friday.